Get Certified Together program is created by Technocofe, your free online knowledge sharing website based out in London.
First, about the virtualization management. Now, virtualization management is the second layer on top of our physical infrastructure. So if you recall from our cloud basic in domain 1, where we covered about different layers of cloud architecture, in second layer we have this virtualization layer. Virtualization layer itself can be deployed on another operating system or can be deployed directly on the bare metal. So if you can recall about Hey everyone, welcome to another episode of Get Certified Together series. This is episode number 41 I am recording today, and like I promised that we will try to cover as many topics as we can in month of November before Christmas time, so that if we go by the plan, then at least we cover domain 5 by end of December, which will be a good head start for us in the next year, because then we'll be having just one more domain left with us, and of course revision, and we can have a first attempt on the exam itself. I'm recording today's episode with the next topic of domain 5, and I'll be doing this kind of like a back-to-back episode. So I'm recording it again this week, and probably I'll be recording again in the next week as well. Just buckle up, because we will be having more episodes coming through. For the domain 5 itself, we were actually covering something around cloud security operations, and what I warned you before as well, that we will be having kind of like repetitive things which we have covered, the topics which we have covered till now, the concepts which we build up from domain 1 till domain 4 will be again repeated in this domain, and with more towards like a point of view of an operational person. That's why when I was going through the next topics and next information around this, the documentation around the domain 5, I was getting same information everywhere, and it was tough for me to think that what new should I tell you guys this time around, because if I really go through with the things which we have covered till now, then you will be thinking that this is something which is happening again, and these topics you have heard somewhere before. And that's the problem with that's the challenge, not the problem actually, with cloud security or any information security, because most of the topics, if you're not facing any new security risk, or if you're not yourself working in the security side, then if you read from an outsider point, if you look at those topics, you will sort of sometimes feel that this is the same thing again and again, which really doesn't make sense. We are aware about different components of cloud. We are aware about what different ways someone can create a threat on the cloud, different layers of the cloud, or cloud equipments, or the services which are part of the cloud application or data. Everything is repeated, and that's how it is, means we cannot actually get away with it. So what actually I try to do is I try to get most of the information from online sources and some of the knowledge which I myself work out day to day, and I try to wrap up these topics of domain 5 around that, because even the book which I showed you in the one of episode, where CBK book about CCSP, also doesn't have much information around these topics of cloud security operations. I'm not sure how to do it, but what I thought of doing is to read through those subtopics from the syllabus and tell you guys from my perspective, as well as getting some information from the online sources, and of course the book as well, so we can have more information around that. Otherwise, if we just follow the book, if you have bought the books by now, if you have the CCSP book with you, then you yourself will find it hard to find the topics specifically for domain 5 in the book itself, because it seems like they are mixed up and seems like they are not covered properly. So I'm not really sure whether they are really not covered in the exam as well, because for sure then it makes us challenging for us. We have to bring on someone who have given the CCSP exam and discuss with them what really comes from the cloud security operations side. So that's another thing which we maybe will be planning in end of December or probably next year, where we will be calling like people who have given the CCSP exam, because specifically from cloud security operations side, I myself is in this confusion that what kind of questions will be coming from this topic, because most of the things are already covered in the other domains. But anyways, we anyhow have to cover the topics and we anyhow have to read through them, even if they are coming back to us. We'll be going in today's episode the same mindset that something might be repeated, and maybe some things you will not find even in official book as well, because those topics or those knowledge which I'll be sharing from my own experience, you might not be able to find them in the official documentation or official books. Alright, that's it for the introduction. I don't have anything new to share beside, because it's just 1 week since we have the last episode. So quickly we move on to the main episode and main content, and before that let's take a quick short break. First and foremost, we have covered security configuration or security operations around the hardware layer, where we discussed in the last week episode around out of band management network and how we should be maintaining a kind of like a baseline firmware security requirement. We can have security strategies for real hardware itself, instead of anyone can come in and can access the hardware, because when we talk about cloud, we sometimes get away with the fact that those cloud applications are really deployed somewhere and really working on some physical server. So access control of those physical server is equally important, and we discussed around that as well. We discussed around trusted platform module and storage and network controllers, the control plane or the management plane of the whole backbone infrastructure. Now moving on to the next layer, we will be discussing today first about the virtualization management. Now, virtualization management is the second layer on top of our physical infrastructure. So if you recall from our cloud basic in domain 1, where we covered about different layers of cloud architecture, in second layer we have this virtualization layer. Virtualization layer itself can be deployed on another operating system or can be deployed directly on the bare metal. So if you can recall about type 1 and type 2 hypervisor is one of the software which enables the virtualization, which help in creating this virtualization layer. And on top of that, of course, we can create our virtual machine, we can deploy cluster, we can deploy maybe containers, whatever fancy term you can hear these days, you can deploy on top of that virtualization layer. Now, of course, virtualization layer itself need to be configured properly with all the security recommendation. Patching of that virtualization layer is not that straightforward, because at a particular instant of time, there might be virtual machines which are already live and running on that virtualization layer. So if you have security recommendation around patching, or you have security recommendation around a configuration change on that virtualization layer, then of course it's a big task, because you have to maybe live migrate the virtual machines onto another physical server and upgrade that one particular virtualization layer on a one physical server. So you have to go kind of like this step-by-step upgrade you have to do, or patching you have to do, which is kind of tricky and which might be challenging if you don't have proper management tools. Now each virtualization vendor or each virtualization provider, if I say, have their own set of management tools. So if you are having a private cloud, then maybe VMware have their own management tools, Red Hat have their own management tools. Of course, when we discuss about public cloud, you might not be directly working on the virtualization layer itself. So what you really work on, the infra which is running on top of that virtualization layer. So your EC2 instances, your Kubernetes cluster, AKS, EKS, everything is on top of virtualization layer. So you might not deal with that right away by your own, but it's good to have knowledge of that as well. Anyhow, what I mean to say is there must be some management tools which will be helping you out in having this like day-to-day management of the virtualization layer, where you can remotely maybe log in into your physical server and you can upgrade that virtualization layer, you can patch something, you can do some kind of like configuration management of that virtualization layer itself. Now this is tricky here, because virtualization layer itself have all the infra running on top of that. So all your virtual machines are running on top of that, and if there is no access control being considered for that virtualization layer, then you will have some threat actor coming in and logging into your virtualization layer and having access to all the virtual machines, which is risky. And if you recall, we discuss about various ways in which, or various kind of risk associated with this virtualization security. We have VM escape, where someone can traverse from one VM to another VM using that virtualization layer itself, because that is an umbrella system on top of that where you have all your virtual machines. So there are a lot of security risks associated with virtualization, and in order to manage properly, in order to keep it secure, access control is really important. Same like we discussed in storage and network controller as well, where these control points are the central points from where you can access everything. And if you don't have your standard access control security measures applied on them, then you're taking a big risk, because if anyone gets into these controllers or these centralized system, then they have access to everything, your all virtual machine, your container, your customer data, everything. Now, of course, when we discuss about a host operating system or hypervisor layer or virtualization layer, virtual machines itself, which are running on top of that virtualization environment, they have their own guest operating system, and we need a separate tool for those guest OS as well. For example, if you have Red Hat Linux based operating system running on as kind of like a baseline infrastructure or base OS, on top of which you have this KVM based hypervisor, which is enabling virtualization across all the infrastructure. Virtual machines which are deployed on that Red Hat Linux based base OS will be having their own operating system. So maybe you are running Windows OS on top of that, maybe you're running another Linux distribution on top of that as a different isolated virtual machine environment. Those guest operating systems should be having their own set of management tools. Now, management tools again can be on the two levels. One is the tools which are managing those guest operating system in one shot, in one go. So your cloud admin or your cloud architect will be having access of a management tool which is managing everything, which is managing all the virtual machines, so they can shut down or they can delete a virtual machine, they can go from one virtual machine to another virtual machine without someone providing them access to particular thing, because they are kind of like administrator of all. So they are cloud admins, and cloud administrator have their own set of tools which give them access to everything. And of course they need it to manage the whole infrastructure, to manage the whole estate. But it again create kind of risk associated, that if someone get hold of that guest management tool, then they can delete or they can take snapshot of existing machine and take it out. It's a two-way process. If you create a AWS account, for example, you will be getting AWS management console with the root access. So that is what I'm telling you about the guest management tool, because using that account you can create, delete, or you can play around in any customer site environment which is created under that main root account. So those guest management tools are one set. Then we have another set of guest management tool or guest OS management tools, which actually manages the application or which actually manages the patches or configuration inside the guest OS. So the Windows virtual machine, for example, I told you about, will have its own server manager, which will be a different guest OS management tool. And all these machines will be storing their own set of data or own set of configuration, own set of customer information. So files or data stored on those VMs have their own risk associated with them. And of course, all these virtual machines need to be monitored as well, maybe for the auditors or maybe for internally for organization level itself. Everyone want to see what is really happening in the virtual machine, or everyone want to see at least the status of the virtual machine, whether they are up or down, or a particular interface is not working or it's going down. So these guest management tools also cover the monitoring aspects of the virtual machine itself as well. So you need them to monitor your whole estate, you need them to monitor your whole infrastructure, so that if something goes wrong anywhere, then you can plan your business continuity and DR or other legal requirements as way you like. Now, one of the important aspects around the cloud security operation is the console access. Console access is nothing but having kind of like a backbone into your infrastructure. So for example, for physical server, you have this KVM based access where you have keyboard, video monitor, and mouse. Yeah, so keyboard, video monitor, mouse are sort of your devices which you can use to access your hardware. When you buy a new physical hardware, they don't have anything installed. They don't have any SSH capability. They don't have RDP because there is no operating system on them. All these SSH, RDP, they comes when you have an operating system installed on your hardware. But to perform that, you need some kind of interface. You need some kind of access into the physical infrastructure or physical hardware itself, which is provided by this console, or sometimes we call it KVM console. It enables us to connect our laptop or connect our configuration device directly into the physical server. This is console for physical infra or hardware itself. There may be a console for each virtual machine as well. So for example, it's completely applicable for virtual machines as well, because I told you in domain 1 that virtual machine is nothing but kind of like an emulation of physical server. So if I'm creating a virtual machine, it should be completely emulating a real physical server. And if it's completely replicating from a physical server, then just like physical server, virtual machine will be having its own console access as well, right? So console access for that virtual machine will be used when our existing operating system is down. For example, we have perfectly running Linux distribution on a VM, but there's something wrong with the configuration and suddenly you cannot SSH in using port 22. You can connect via IP address of that VM. So you need some kind of backbone to connect to the virtual machine as well. So virtual machine itself have their own virtual consoles. Now virtual console play a tricky part because normally a simple configuration mistake which we sometimes makes is we make root access disable via SSH, but root access is normally enabled via console. So if something goes wrong with your application or your virtual machine and you need the root access to that machine, it makes sense to keep root access open on the console, because not everyone will be having access via console or virtual console. Your end application users don't have access to your virtual console. So as an administrator, it makes sense to keep it open for root. But this root access via console, it can be taken advantage by someone who want to perform something wrong into your application or into your machines, into your infrastructure. So someone can use those root credential, use that virtual console access or physical console access to get into your system and perform all these kind of changes in the backend without even going in via the main network itself. So without even going via SSH or RDP, they can do everything in the backend, which no one will be knowing. So that's why this console or this KVM based access control is as critical as just normal access control via SSH or via those guest user account which we create in any operating system. We just have to remember that there is a default root or there is a default administrator account which can be accessed by a backend, and it's really important that we take in consideration that access control as well. Normally we segregate these two terms in between local and remote access, because as name suggests, means if you are doing access via SSH or RDP, you can do it from anywhere. So it is kind of like a remote access. But when you want to do a console access, if you're talking about private cloud, then someone have to go into your data center and connect via laptop to a real physical infrastructure. Then only you can do console on that hardware. For virtual console, you need access to that management guest tool, which I told you about, like for example, AWS account or Azure account, not normal account, but a proper root account, which have access to all the application or all the virtual machines. And then you can perform this virtual console using that guest tool. So that can be considered as local access control. So there is a difference between local and remote access control, where remote access control normally covers RDP or SSH sessions. Local access control covers access via console. Another challenge which is with the console based access or access via this backend networks is you cannot apply your normal single sign-on or your multi-factor authentication strategies on this console access. For example, if you have this private data center and in data center itself you gave someone to go into the data center and plug in their device. Once they are connected to that device via backbone network, it's quite tough to implement your normal organization level single sign-on strategy there. In this scenario, someone is connected via different isolated network, front backbone out of band management network, and you cannot have same strategy implemented because you are not going via any main or any management network. You are completely directly plugging into the device and getting that access. So it's quite tough to implement that strategy here, and that's why it brings another challenge, how to control or how to have this secure access control via this local console based access. Now we have already discussed about network segmentation, which is kind of like a day zero requirement for any organization when they are setting up their cloud-based estate, be it private or be it public. Let's dive a bit deeper into the same concept, because the network isolation or network segmentation is the final goal or is the requirement. How we can achieve that is something we can discuss now. And one of the commonly used way to achieve this segmentation is the use of VLANs. Now VLANs itself are on the layer 2 of the OSI model or even TCP IP model. They provide segmentation based on a number which is associated with each network. So for example, you can have range of VLANs defined into your network, and you can associate a particular set of network with a particular VLAN and associate another set of network with another VLAN. So you can have this segmentation, or you can have isolation based on VLANs into the same network. There is no need to divide and create new network for each application or each server. You can use same network, but you segment it based on use of different VLANs or different VLAN numbers. Another concept around network security or network configuration security is use of TLS. Now TLS is transport layer security. We commonly use it in HTTPS based web access, where we have this TLS security applied on access via port 443, and you have any application or any packet which is going in and out from that web application will be encrypted and will be having this certificate associated with it, so that it can be treated as secure, and it will be then tough for someone to perform this kind of like man in middle attack and try to read what is going in and out. So transport layer security actually help us out in that aspect as well. We also use DHCP and DNS quite commonly in any network. Now DNS is nothing but when you resolve your domain names and get IP address, because not everyone can remember the IP address associated with a server or associated with an application, but they can easily remember, for example, google.com or facebook.com. They can easily remember the domain names. DNS perform that domain name resolution based on the domain name which you provide. It will resolve that into the IP address of that server or IP address of the application, and it will route the traffic. It will help in routing the traffic. It will not route itself, but it will provide you IP address, and then using that IP address, traffic can be routed to a particular server. DNS security is quite important these days, because I think I mentioned you guys about my first ISC Square conference, where one of the speaker was from Infoblox, which is a DNS provider, and he was telling about all these kind of different attacks where someone can create fake domain names, and you as a legitimate user will try to open a particular domain name, but because of some spelling mistake in the name or some minor addition of the letters into the domain name itself, and you will be then going into a spoof website, which actually will be kind of like a lookalike website of the real one. All these different ways of phishing attacks are happening, where you have different domain names which look like same but registered by the hacker or registered by the people who want to extract the information out of you. So DNS itself have a lot of security risk associated with it. We use DNS security or DNS security extensions. I'm not going in detail, but which is kind of like a security layer, same like TLS security, which make this whole DNS poisoning or use of DNS to perform the attacks quite limited, and it help in controlling that. Besides spoofing, another sort of attack related to DNS is denial of service, where an attacker can overwhelm your existing DNS servers. So anyone who is trying to resolve or trying to send a legitimate query to the DNS will not be able to resolve that. So it will be leading into your availability of your application, or it will be making it tough for people who are working inside the organization to access something which is outside, because your DNS server itself will be not able to resolve the domain names because of that denial of service attack, which is flooding the whole DNS infrastructure. Now, IPSEC is another important concept, because IPSEC will perform the security of the IP packets which are going in and out from one application or one server to another server, or like these days we quite commonly use VPNs to connect to our physical infrastructure or to connect to our office environment. These VPNs or virtual private network use IPSEC quite commonly, because IPSEC then enables the encryption of the packets which are going from your remote laptop or your remote machines to the main server or main network. So anyone who is trying to read or who is trying to get access of the information which is going from your laptop to your organization, which is maybe in a different city or maybe in a different country itself, VPNs help securing that by using IPSEC. IP security itself is mainly on the network level. It's helping supporting the network level of authentication. It help in performing data integrity, of course encryption as well. And use of IPSEC can help any organization to spread their employees all over the world, because it will keep everything secure, and everything which is going on the internet will be secured using the proper encryption mechanism. Alright, that's it for today's episode. We have covered today quite a lot of topics spreading around different layers of cloud. So we have covered things around virtualization management tools, guest operation management tools, KVM based local access, and various kind of strategies for secure network configurations. In next week episode, we will be covering concepts around hardening of the operating system, availability of different application or different clusters, and of course we will drill down more into how we can back these application or back these infrastructure properly and how we can perform other bits around cloud security operation. Maybe some of the topics again will be getting repeated, but like I said in the start of the episode, that this is way domain 5 looks like. Most of the topics are repeated and most of the topics will be coming back again and again. If it's required, we'll go with the topics again, so will be good revision for all of us as well. I hope you have registered for certified in cybersecurity exam. If not, then like I mentioned before, just go for it. It's completely free and it will help you become a member of ISC Square. I'll try to record next episode next week as well. Maybe by December we'll be having 2 more episodes. All right, that's it. Goodbye and good luck.
Thank you for listening to Get Certified Together. If you loved our content, then please like and subscribe from your favorite podcast platform so you don't miss the notification for our next episodes and announcements.